Okay, so what you want to do with trigonometric identities is there are sets of, really, they're called identities because they're laws that always exist. Like they'll always kind of work out together. Oh, my thing is glitching. Is my window glitching for you? Is it okay? Oh, it's okay though. Okay. Ooh, that's gross. Um, so what you have, I mean, you have the simplest ones. So the simplest forms of a trig ID are sine and cosine. And they're the simplest because, I mean, if you think of the Pythagorean theorem and if you think of the unit circle, sine and cosine are those very fundamental ones that just kind of exist. So that's really the simplest form. You then have what are called quotient identities. You remember talking about quotient identities? Okay, it's okay if you don't. So quotient identities, for example, you have tangent, which is equal to sine over cosine. And then you have cotangent, which is cosine over sine, right? So then you have your simple ones, you have your quotient IDs, and then you have what are called reciprocal identities. I don't know if you remember those. Reciprocal IDs. And so these ones include, let me move it a little over here. So you've got secant, which, do you remember what the inverse of secant is? Yes, it's 1 over cosine. And then you have cosecant, which is 1 over sine. So again, this quotient reciprocals. And then the last ones, which are probably the most complex, complicated ones, are called the Pythagorean identities, which, as you can imagine, are derived from the Pythagorean theorem. And the most simple one is sine squared plus cosine squared equals 1. The secondary one is 1 plus cotangent squared over cosecant squared. So I have to think in my head. And then the third one is tangent squared plus 1 equals secant squared. So now I do have methods of like how to memorize like the Pythagorean IDs, like how to work them out. But we can do that like at a different time if you want. Okay. I don't know necessarily what your timeline is for today. So I'm gonna leave these here because again, like when you first start working with these, you just want to keep them to have them for reference because you know it's kind of hard to just bring them out of your brain. Like I only know them in my head because I've been working with them for so long. And I've learned different tricks to memorize them, essentially. Yeah. I mean, you definitely need these though. Like, I don't know what your plans are after Math 4, like honors pre-calculus, calculus, like any of those upper level math classes. You are expected to know these like the back of your hand. Like, you need to know them 100%. Okay. Um, and again, I can go through like different tricks to kind of remember them, but you know, that's a different one. So, with this problem we have here, we're proving that this equation here, that secant x minus tan x sine x equals 1 over secant. So what I like to do is I just like to box this right side and just like not really work with it until the end because this is the answer I have to get to. Okay, like I'm proving that this works. So one thing you'll notice is, again, I like using thetas, so it's fine. So I'm going to use those, but you can use x, you can use really whatever you want. Okay, so first thing I'm going to do is when I look at this, right, like secant, is there any simpler way to write secant theta. Look over here on the side here. Right, 1 over cosine. So I'm going to write that. Okay. I'll put my minus sign, and then I've got tangent theta and sine. Hello. So tangent theta, I can rewrite that as, yep. So now, I also have, remember this sign is here. So I'm going to keep that sign up in the numerator because it's like multiplying together. So they're just next to each other. Now you see that we can actually, these are two fractions we're subtracting, and we can combine those because they have the same denominator. It's like one of the basic rules of, fractions. So what I'm going to do is I'm going to write this over one fraction, right? And then I have 1 minus sine times sine is going to be, boom, look at that. You already got it. You're acting like you don't know. You know. Okay. So now I'm really almost there, right? Because if I look at where I am right now in the process, the answer I have to get to is 1 over secant. And right now I see that there's a cosine here. So anyway, so let's go through. So now let's look at this numerator. Let's kind of, that 1 minus sine piece. Okay, hold on, taking a little while. So I used to like to highlight any kind of Pythagorean identity. How do you think I knew that was Pythagorean? What do you think? I feel like you've got it. It would. So this 1 minus sine squared is a modification of sine squared plus cosine squared equals 1, right? So, and this is something, again, I used to do this with my students. I'm gonna use, you know what? Let me just come down here real quick. So, I don't even know the best way to do it. Let me insert another page because I feel like, come on. It's just glitchy. Okay, and what did that say? All right, so it was sine squared. That was the original one, right? And so this usually is something that goes on in my head, like my brain thought bubble, right? But I know some people like to just do it on paper. Um, so 1 minus sine squared, if I wanted it to say 1 minus sine squared from the original one, what would I have to do? Make it a little bit easier. I think you got it, but so again, we want to say 1 minus sine squared. So just take away the sine squared. So I mean, yours would have worked out, but you're doing like 3 steps versus like 1 step. So I would get cosine squared equals 1 minus sine squared, right? Well, actually, it does matter because look here. Remember, look what we highlighted earlier. The sign is negative, right? That minus there. So, and again, this was something I used to do was I would then, this is why I have folks highlight it, is like, ooh, okay, 1 minus sine squared is the same thing. So the equivalent of 1 minus sine squared is cosine squared. You got that? All right, keep that in your noodle there, your brain. So I'm gonna put cosine squared at the top and then keep cosine on the bottom. Okay. So now it gets a little simpler, right? Cosine squared divided by cosine. One of them cancels, right? So I've got cosine theta. So now it seems like, oh my God, I'm done, like cosine. But now remember, we wanted to figure out, is that equivalent to 1 over secant? And so, what do you think? Yeah, no, it would be. So now the reason, go ahead. Well, no, so it's not 1 over cosine. So this is where it's a little bit trickier. Now, if it said secant, like say it just said secant, right, that would be 1 over cosine. But also, you can write, like in reciprocal identities, like cosine can be 1 over secant. And yeah. Well, and that's what's so funny about, oh, sorry, sine, oops, sine is 1 over cosecant. And that's what's so interesting about this. So, yes, these do match. And when it says, um, I might erase this 'cause that's just confusing a little bit. Um, so when it's, oh, that's ugly. I don't like that either. So when it says prove this, that means that the problem is going to work. You just have to figure out the steps to get there. So in this problem, we just verified what we had to do. What do you mean? So it's mostly showing you logical thinking, like so going from one step to the other, like being able to kind of get through that process. If we really go into the dynamics or like the sequence of where all these identities come from, they're all essentially related to unit circle, right? Like if you look at your unit circle, which is like a kind of a natural phenomenon in the world. Oh, this is so ugly. Um, when at like say like 45-degree angle, right? And you don't have to say yup, just agree with me, but so like you have like square root of 2 over 2, square root of 2 over 2. Um, the x value is a cosine value and the y value is a sine value. Essentially, what these identities are proving is that all of these different things can be equivalent, and that naturally kind of occurs in different phenomena throughout like the world.